further. So we did Armstrong number, right? We did. We did the last time around Armstrong number, that to accept a number from user and check whether it is Armstrong. Right? We had done that. That so in that we have different flavors. Let's try to cover up those different flavors in that. So if I were to do, you're able to see my screen, right? So I have integer n, right? So I have integer n as the number. Then I will take a backup. Then I will also require a sum, also require an r. And then from the user I'll take the number, enter a number, and that I will put it in, and n, right? And then we will put a loop while your n is greater than 0. Keep on iterating, get the r, which is okay. First we'll take the backup of that number so that later on we can compare it. So whatever is n mod 10, put it into r, and sum is plus equal to r cube, and n is divide equal to 10. And then we will compare if your sum is equal to the backup. You will print a Armstrong number, else not Armstrong number, correct? First flavor we had done, and the second flavor which we had done is accept 5 numbers and check which all are Armstrong, right? So what was that? That was just, and I'll copy paste that, put it on a separate file. So that was, I would take a variable I or a j and take this task that many times, right? So that would ask me to fetch 5 numbers and display the Armstrong numbers between these 5, right? So here we had reached that day. Now my question is, from 1 to 1000 display all the Armstrong numbers. Between, my question is, display all Armstrong numbers between 1 to 1000. So the output should be 1, 153, 370, 371, 407. These are all the Armstrong numbers between. Yeah, now my question is, will we have to accept a number from user now? So which number was the number which we would accept from the user? That number we would check, correct? Now as we are not going to accept any number, now what will we check? From 1 to, and now we are checking for 1, right? So we'll put that in the backup, okay? And now this I will evaporate, right? Okay, but if I change, see, now what we are doing is, whatever is in I am storing in n, let's say. Let's do it like this. Whatever is in I am storing it in. So what is in n? First time 1, right? See, if I dry run this over here itself, I have how many variables? I, right? So in the first iteration, what is in I? 'Yes, 1, right? In the first iteration, what is the value of I? 1. Then whatever is in I goes into N. So in the first iteration, what is the value of N? 1 only, right? And now I will check for whether 1, what is the sum of the digits, right? So what will come in the sum? What will come in the sum? Is 1 greater than 0? 1. And then what will I compare after this loop? The sum and the, yeah, that we are doing. No, after this, okay, see now. How will you read this? Is n greater than 0 means what? We'll read it as is what? 1 greater than 0. True or false? Come inside. Last digit of 1. What is the last digit of 1? What goes into R now? R has 1, right? 1 mod with 10. 1 mod with 10 will give you 1. And we have to initialize the sum to be 0. So the sum will be 0 where? Will the sum be 0 over here, or will the sum be 0 inside the loop? At which we have to. No, no. So where will I put sum equal to 0? Outside the loop or inside the loop? Outside the loop means it will be some 0 only for I when I is 1. Then when I is 2, again I have to make it 0. For I is 3, again I have to make it 0, right? I have to sanitize this sum 1000 times, correct? So it will be inside the for loop, not outside. So now when I is 1, sum is 0. And we are checking is 1 greater than 0. Answer is true. 1 mod 10. What is the last digit of 1? Last digit of 1 is 1. 1 goes into R. And then 0 plus 1 into 1 into 1. What goes into sum? So sum has been updated to 1. And n is n divided by 10. N becomes 0, right? And now loop goes up. Is 0 greater than 1? Is 0 greater than 0? False. The loop, this while loop will finish, and then directly I will compare what outside. I will compare the sum with the n has become 0, correct? So I'll compare the sum with the I. And if the sum and I is same, I will just display that I. I will just display that I. And if it is not, I will not do anything else because I have to just display the Armstrong numbers. If it is not Armstrong number, don't do anything. Correct? So this code will display me all. Now when this finishes, I plus plus, I becomes what? I becomes 2 and again sum becomes 0. Correct? And now, and that I goes into n. Now what does n become? 2. Now is 2 greater than 0? So what will you do? What is the last digit of 2? 2. And then what will you add to the sum? 2 into 2 into 2, 8, right? Becomes 8. And now n divided by this. So 2, the last, if I remove the last digit, what is left in 2? 0, correct? And then is 0 greater than 0? False. And what will I compare? 2 with 8. Is it same? So it is, this if will not be true. So it will not display 2. Getting it what I'm trying to do? So you have to understand the concepts very thoroughly. So now if I try to run this code, we should able to see all the Armstrong numbers between 1 to 1000. Okay, so yes, no, maybe. Okay, now if I give you a task to find the sum of digits, we have done that, right? So if let's say if I give you a digit 153, okay, so what is the sum of digit of 153? What is the sum of digit for 153? 9, right? So you can do this. You can do this program very simple, right? So how do we do that? Very simple way of doing it is we don't need this for right now. So directly you can. So what did you say? Integer n and printf accept that number. My question is a higher level than that. It's just the basic version of that. Enter a number and you will scan it in which variable? Percentage and n, right? And now to find the sum of this, you will say while your n is greater than 0, come inside, r is n mod 10, sum plus equal to r. Yeah, I'll declare that. Yeah, I'll declare that. And divide equal to 10, correct? And you will come outside and we will just print a percentage comma sum. And now we will just sanitize the sum with 0 and declare sum and r as integers, correct? So now if I run this, code and I enter 153, what happened? Line number 7. Okay, the double quote closes over here. The double quote closes over here. So now if I run this and I enter 153, it should give me 9, right? Now my question is 9 a single digit or double digit number? Okay, now what if I enter 777? What will be the output? Is 21 single digit? Now take the sum of 2 and 1. What is the answer? So I want that as an answer. So the answer of your program should be sum of digits till it rounds up to a single digit. What is my question? Find sum of digit till it rounds up to a single digit. So now my question is, if I enter 7777 4 times, what should be the output? Yeah, is 28 single digit? Then 10. Is 10 single digit? Hmm. So what is the answer? So output should be 1, right? So how would we do that? That is my question. So this is what I am expecting you to do. So in the earlier program, when we had done sum of all find all Armstrong numbers between 1 to 1000, we had a for loop. Inside the for loop, we had a while loop, right? In that program which we did. So we had a for loop, and inside the for loop we had a while loop. See over here. You see my screen, right? So we had a for loop, and inside the for loop we had a while loop, correct? So we can have any permutation. For inside a while inside a for, while inside a while. So what logic will you apply for this question? Is my question. Is the question clear to you first? Yeah, not tell me. Hmm? Yeah, what should be your algorithm? So if I enter a number and that number is 777, okay, let's try run that. So if I enter the number, it is 777. What will come into n? N will have 7. N will have 777. So if I ask a number and the number is 777, that number goes into n. Then what are you storing in sum? 0. And then is 777 greater than 0? You will say yes, true, and then you will say r. Then what will come into r now? One more variable, r. So what will come in r? What will come into r? 7. 7 will come into r, and then what I'm adding? 7 plus 0 is 7, and my n becomes 77. And now what will you check? Is 77 greater than 0? So what will you say? True. And then again it will come up, and then what will be in r again now? So in r you will have again 7, and what will you do? Add some with r, this becomes 14, and your n becomes single 7, correct? And now again you will check, is your 7 greater than 0, correct? And that will be a true, and then you will add 14. So the last digit of r will again be 7. This last 7 will come into r, and you will add the 21, and now your n becomes 0, correct? And now when you check for the last time, is 0 greater than 0, loop will break, and you will display 21, right? Now but my question is, 21 also is not single digit. Now what will you do? You have to fine tune this till single digit. So this will again be sent to this machine for further fine grinding. Yes or no? See, if he enters over here, enter number and he enters 3. Is there any need to grind that 3? So when will we do the grinding? No, no. If the number which I am entering is greater than 9, okay, or while it is greater than 9, while it is greater than 9, then you will do this grinding part. then you will do this grinding part, right? So if you enter a number and he enters 3, 3 greater than 9, loop will break and directly you will come and display the n, right? And it did not go into sum only, no? It did not go into the sum. See Aryan, be with me. So if he enters over here 5, 5 came in which variable? 5 has come in which variable? 5 is in, if I enter 5, 5 will go in which variable? N. So now n has 5. So now what is the condition? Is no, don't read while as read while as is while doing dry run. So is 5 greater than 9, true or false? So it will not go in this parent while. So directly it will go out of the parent while. So at which line is the parent while ending? It's ending at which line? Parent while is ending at parent 18. Directly it will go at the end of line 18 and display n. So what will be the output? 5. So the number 5, some digit is 5, correct? Okay, what now if he enters 13? Now, how will you read this? Is 13 greater than 9? True will come inside. And then what we will do is this inside part, what will it do? It will calculate the sum of 13. So what will come into the sum after the loop finishes? 4. And then we will send this 4 back over here. So what have we done now? Send this 4 to whom? N. So now what does n become over here again? 4. Now it goes up. Is 4 greater than 9? Is 4 greater than 9? False. False. And now that it directly will come and display you 4. Getting it? Okay, let's try with 176. Let's try with. So what comes into n? Now you tell me the dry run. Okay, you will tell me the dry run. What comes into n? What will you check in the first? What is true or false? True. What will you do? You will come inside the loop. Sum will be 0. And this loop will find the sum of 176. Correct? Right or wrong? So this will then sum will become 0. Then r will become 6. All that stuff you know, right? So I should not wasting time on that loop. So r will become 6. Then it will add 0 plus 6. Then sum will become 6. And n will become 17. Yes or no? And then is 17 greater than 0? Blah blah blah. Then r will have 7. Then sum will have 13. And then n will become 1. And then r will have 1. Then sum will have 14. Right? And sum will become 0. N will become 0. When n becomes 0, loop will break. So when loop will break, what is in the sum? The sum of 176. So what is it? Yeah. So now what is it? When this loop will break, when this inner while loop will break, what will be in sum? 14. Then what am I doing? I have to again fine grind this 14. Correct? So I put this sum back into n. Now what does n become? 14. And now we will again coarse grind this 14. Now is 14 greater than 9? So we will set it for grinding. So what will it become? Now what is the sum of 14? So after this inner loop will terminate, sum will have 5, right or wrong? And then again we'll send this 5 for fine grinding. Now what will come into n? 5. Now is 5 greater than 9? And then the outer loop will terminate, and directly we'll go at the end of the outer loop. So what will be display? So if the input is 176, what is the output? Getting it? Or still not? This is the level of programming we have to reach. So now if I run this code and if I enter 176, I should get 5. Got it? What if I enter 4 times 7 now? 4 times 7 should be, got it? The output, understanding the output is not a big deal. Dry run is the biggest thing which you have to understand, focus upon, because no online will show you the dry run. They will, so that if you go to, let's say if you go to any of the sites, okay, let's say you go to some of digits in C. So now you go to any of the trending website, directly what it will give you is the program. This is the program it is giving you. You see? But now it will not give you the dry run. Dry run you have to understand on your own. So getting the code is job half done. Understanding the code and how the loop is working, that is the biggest challenge. That is what we have to learn. So this is why we are doing loops for. Okay? Okay. Now next question. What is a prime number? Yeah, so if I ask the user to enter a number, can you check whether it is prime or not? So I want you to share your screen and do the code for me. I'll give you 5 minutes, and if you're stuck, then I'll assist you. So let me go to security and share screen. Yeah, now you can share your screen. Yeah, come on. On top, give a comment and write the question. Yes, now how will you do this? So a number which divides by 1 and by itself is, so run a loop from 1 till the number, run a loop from 1 till that number. Run a for loop which starts at 1 and ends at that number. Yeah, I equals to, yeah. And now come inside. Now if your number, so now if the n, see, I'll first show you the logic in paint, then maybe you can code it better. See, you stop sharing. Okay, okay, I'll snatch it, no worries. So I've snatched the sharing. As an admin, I have the privilege that even if you don't stop, I can still share. So I was doing that. So let me go to the drawing board and first show you the logic behind it. Then maybe you can code. So the session stop. We can join on the same group, same chat. So what is in your n? N is, let's say, 7. 7 is prime. You can see my screen, right? The paint screen. So I will run a loop from where 1 to 7, correct? So my loop will run from 1, 2, 3, 4, 5, 6, and 7, right? So which is the iteration of this? The variable is I, right? So what is the value of I in the first iteration? What is in n? 7. And what is in I in the first iteration? 1. And now what I will do is 7 mod with 1. 7 mod with, so how will you write that? How will you write 7 mod with 1? You will write it as n mod with I, right? Because we are doing a loop, right? So if the remainder is 0 means what? So this number goes in this table, correct? This number goes in this table. 7 goes in one's table. 1 sevens are 7, correct? Yeah, there, Aryan. So which means that this number n goes in the one table, right? So whenever it divides, I will increment a counter. So I will take a counter and increment it by 1 whenever the division is possible. So let's say this is a counter variable. So what is the value of counter? Initialize to, so counter has, now does 7 go in one's table? I'll increment the counter. Does 7 go in 2's table? Counter remains 1. Does 7 go in 3's table? Counter remains 1. Does 7 go in 4's table? Counter remains 1. Does 7 go in 5 table? Does 7 go in 6 table? Does 7 go in 7's table? Counter becomes 2. After the loop terminates, now the loop terminates over here, right? I will check the value of the counter. If the counter value is 2 means, yes, as simple as that, simple logic. So if counter is equal to 2 means the number is prime, right? So let's do a higher number 8. So if my n is 8, my loop will start at and end at 8, end at 8, right? Start at 1 and end at the number, right? Now counter initialize to 0. Does 8 go in one stable? So counter increments to, then does 8 go in two stable? Counter increments to 2. Does 8 go in three stable? Counter remains 2. Does 8 go in four stable? 3. Does 8 go in 5 table? Does 8 go in 6 table? Does 8 go in 7 stable? Does 8 go in 8 stable? So what is the value of the counter at the end of the loop? If it is 2, its number is prime. If it is not 2, else not prime, right? That's what we are trying to achieve. So what we are doing is we are running a for loop over here from 1 to n, and in the for we are checking if n mod with I equals to 0, means if it divides, then what are we doing? Counter plus plus. And after the end of the loop we are checking the value of the counter. Got it? So now you do and show me. Okay. Done. Now first put the body of the first initialize sum and initialize counter and make it 0. Initialize the counter and make it 0. Yes, after the for loop, yes. So will you check? Yes, correct. You increment the counter. Put a if on line number 12 also. No, if you know on tile number 12 is a if. Line number 12 also there will be a if, right? You're checking for a condition. Yes. Once the no else. When the loop terminates, you will check for the value. When the loops terminate, you will check for the value of the counter. Don't check the value of the counter inside the loop. Close the for loop here. Yes. And now command line number 15. Here you bracket. Correct. Now, yes, please. You declared and you did put and in scanf. The scanf is not having a and. Enter 7. Yeah, enter 8. Got it? Okay, now enter a number 100. Yeah. What is it? Yes. So now how many times did your loop run to check whether 100 is not prime? So go to the end of line number 11. Go to line number 6. Go to line number 6. Yeah. Go at the end before the semicolon. Before the yeah. Put the count comma. Give a comma and make a variable called loop counter. No space. There should be no space in a variable name. There should be no space in a variable name. Yeah. And now initialize on line number 10, initialize loop counter equals to 0. Yeah, semicolon. And now go at the end of line number 11, end of it. Go outside the curly bracket. Yeah, hit enter and say loop counter plus plus plus. Yeah. And now at the end of line number 22, enter and display printf percentage d slash n percentage d, or you can say a number of iteration is percentage d of iterations. Yeah, okay. Okay. And after that, comma, write a loop counter. Yeah. After comma, write loop count and give a semicolon and now hit now run the code and now give 8 give 8. So 8 it is telling not prime. Enter and it took 8 iterations to tell you that it is not prime. Correct. Now hit and run again and enter 100. So it will tell you not prime, but how many iteration is it taking to tell not prime? 100 iterations, right? So is there any faster way of doing it? So it should tell me not prime, but in a very fast way. Counter hits 2. Counter 2 is still prime. No? Yeah. So go at the end of line number 14. Then end means after the semicolon. Hit enter. So you can say if counter greater than 3, break. Greater than 2 and enter. As a single statement, no need to give brackets. Yeah, break. semicolon. Now run. Now enter 8. Now it is telling in only 4 attempts, right? Now enter 100. It's telling only in 4 attempts, correct? Is there any further faster way? Are you getting what we are trying to do? We are enhancing the performance. It's the time complexity. We are reducing the time complexity of the algorithm. So is there any other more faster way? You keep a note of all these programs. So you copy them in your notepad. One flavor, this version 1, version 2, version 3. So that because at the end you will have the latest version, right? So all the previous version would have been modified. So you won't have them to fall back upon. So you should know what enhancement we have done. Make a note of all. So remove the count, remove the if and break one. That is version 1. Yeah. Yeah, control X. And now again make one more. That will be a version 2. No, keep the loop count. Okay, you want to, okay, in the first we don't have the loop counter also, right? Hmm. Okay. Okay, then make the first one without the loop counter and without the if. Save it. So say prime version 1. Prime 1.0. Save it as prime 1.0. Make a folder. Don't save it at any random place. Hello. Don't save it at any random place. Make a folder by your name. No, don't save on desktop. Never save your work on the desktop. Desktop is for housewife. So you save it in D drive, E drive somewhere. Go to this PC. Go to D drive. Yeah, make a folder by which you can recollect RN programming or RNC programming, whatever. Never give a space while naming folders. Give us hyphen in between if you want to, or give underscore. Enter. Come inside. Now, now enter. Make a folder by prime number, so that you can put all the version in that folder. Easy access. You'll get prime number. Okay. Now come inside. Now say prime 1.0. No, give version 1. Just say prime 1 underscore 0. 1 underscore 0. Prime 1 underscore 0. After prime, after E give 1 underscore 0. Enter. Yeah, now add the loop counter and make it prime 2.0. Prime 2.0. Yeah, and what changes you have made over here? You have incremented the loop counter and you have displayed the loop counter, right? Okay. The third, to make it faster, so that did not contain the counter variable, right? The 2.0 did not contain count greater than 0. This is version 3. 3. So this is your, so in this, what did we add? We added the, okay, and the counter broke at 2, right? After, if the counter exceeds more than 2, it will break, correct? Yeah. So, okay, now anything faster than this? See, let me come back to the drawing board, okay? I'll share my screen. So, I know that numbers which divisible by 1 and itself are prime, correct? if a number divides by other than these two numbers is a not prime number. See, I am sure that any number will divide by 1 and by itself. By 1 and by itself, any number will, right? So, by these two numbers, any number will divide, correct? So, I will skip these two numbers. And if a number, if I skip 1 and itself, what is left then? 2 to n minus 1. 2 to n minus 1, correct? So start the loop from 2 and go till. If that number divides by any number between this range, it is not a prime number, correct? This logic we will apply, okay? And for that we have to study flag. What we have to study? The flag variable. This is also a very interesting topic. Flag variable. You should be able to understand this, okay? Maybe tomorrow I'll brief you on what is a flag variable. Have you seen flag in your programs? You set to integer flag equals to 0 and then set it to 1. Have you seen any programs which has flags? So very interesting concept this is of understanding how flag works. Okay. So maybe tomorrow I'll explain you this code and we will go in the flag part also. Okay. Then tomorrow same time. Yes. No, no, no. Because now here, if I take 100 and 100 divided by true straight away, I will not go at 3 only. Yeah, once or at least faster than that. If 100 divides by any of these numbers, means 100 is not prime. So if I'm searching for my key in the drawers and I find my key in the first drawer, will I search in the other drawers? So at the very first attempt, in one attempt, I can say 100 is not prime. The loop counter will be 1 only. Getting? Tomorrow I'll explain this and tomorrow we'll do flag variable. Just remind me. Very interesting concept in programming. How flags work. Okay? Okay. Bye. Arya.